Hi guys, this is Hemant. In this video, I'm going to solve first question of MAT 104 end term exam. So let's start working it on a paper now.
Let's have a look at the question first. In a room containing room of volume 20,000 cubic feet, and inflow rate is given as 600 cubic feet per minute, and mixture will exhaust at rate at the same rate, 600 cubic feet per minute. So we need to find out what is the amount of fresh air at any time, y of t as a function, assuming as fresh air inside that room y of 0 equal to 0. That means the room do not consist any fresh air at time t equal to 0, and we should also find after what time 90% of the air be fresh. So it is given that y, let us consider y as amount of fresh air in that room at any point of time. Inflow rate is given as 600 cubic feet per minute. Outflow rate is given, volume of room is 200 cubic feet. So dy is the rate change in the amount of fresh air. It is the rate of inflow of fresh air minus rate of fresh air moving outflow. So actually it's in this room the fresh air is entering at 600 cubic feet per minute. So as the volume of this room is fixed, so this fresh air will be mixed up with the total air, and the some quantity of fresh air will also be exhausted in this outflow rate. So it will be equal to, so rate of inflow is equal to 600 cubic feet per minute into dt minus outflow. So let the outflow rate is also 600 cubic feet per minute into the density of fresh air in that particular volume. So it will be equal to y by 20,000 by into dt 20,000. So dy by dt equal to 600 minus, so if we cancelling this out we will get 0.03 y. By rearranging terms we will get dy by dt plus 0.03 y is equal to 600. So it is of form like dy by dt plus p of t into y is equal to u of t. So it is a non-homogeneous first order differential equation. So we know the solution of this kind of equation, which is the solution is y of t equal to the general solution, as we know y of t is equal to e to the power minus h into c plus integral e to the power minus h into r dt. We know this general solution. So if we consider these two equations, p of t is equal to 0.03 and q of t is 600. So here h implies that integral of p dx. h is integral p dx, so which is, we can also call it as integration factor. This is the general solution of that differential equation. So by substituting those terms, we will get e to the power minus h c plus integral e to the power h into q here q is that implies 600 here, so by comparing we will get q as 600 and h is as I said earlier, h is equal to integral p dx p dt, which is equal to integral 0.03 dt is equal to 0.03x. I'm substituting this h value here, which is equal to e to the power minus 0.03 into c plus integral e to the power 0.03 into q. Q is 600 dt is equal to e to the power minus 0.03 c plus, here by multiplying e to the power minus 0.03 into e to the power plus 0.03 will get 1 into 600. This has to be integrated. This is in the form of e to the power ax, so it will be e to the power minus 0.03 into integral 0.03. E to the power 0.03 is e to the power 0.03 by 0.03 into 600. If I were to put t here, variable, so my equation is e to the power minus 0.03 c plus 600 by 0.03 will be 20,000 into e to the power minus 0.03 into e to the power 0.03 will be 1. So y of t will be e to the power minus 0.03 c plus 20,000. So we were given that in the question itself y of 0 equal to 0, so I am taking t as 0, which is y of 0 equal to so I forgot to put t here, so e to the power minus 0.03 into 0 c plus 20,000. So this will be c plus 20,000 is equal to y of 0 equal to 0 is given, so c is equal to minus 20,000. So and you are asked to find the amount, what is the amount of fresh air y of t at any time. So I have to submit this c here. So y of t would be e to the power minus 0.03 t into minus 20,000 plus 20,000 is y of t. So here we got the answer for the first part. So now we have to find a time t at which the percentage of fresh air, that is the percentage of y should be 90%, that is y of t is equal to 90%, that is 90 by 100 of of volume in that room, that is 20,000. So it should be, so by substituting this above equation which we get earlier, is e to the power minus 0.03 t into minus 20,000 plus 20,000 is equal to 18000. So e to the power minus, by solving this we'll get e to the power minus 0.03 t into minus 20,000 is equal to minus 2,000. E to the power minus 0.03 t is equal to 1.
ln on both sides will get 0.03 t is equal to ln 10 to the power minus 1. So t
is equal to
ln 0.1 by 0.03. By calculating this in calculator we get t is equal to 76.8. So we can take it approximately as 77 minutes. So that's it.